Yeah, um, good morning, my dear students. Now I want to explain a topic sample embedded system using msp430 microcontroller. Okay, see here the example they have taken as the weighing measurement. Okay, so weighing measurement using msp430 and weighing measurement using other microcontroller. So based on this comparison, you are going to understand the importance of MSP430 microcontroller. If you observe the block diagram, here for weighing measurement, so here the weight. So this weight is to be measured, and here this weight is going to be applied on the Wheatstone bridge, and the Wheatstone bridge output will be given to the op-amp. Op-amp output will be given to the ADC. Then digital value of this ADC given to the microcontroller. And through LCD controller, we are going to display the weight on this LCD screen. Okay, and let me see a little bit about its working. Initially, the Wheatstone bridge, which is at the front side, will be in the balanced condition. If you observe on two arms, the resistance is R plus 2R, R plus delta R, R plus delta R. On other two arms, R minus delta R, R minus delta R. Hence, the resistance is equal here. The bridge is balanced. When bridge is balanced, this V plus value and V minus value is going to be the same. V plus minus V minus is going to be the same. Then V out is nothing but 0. As per the op-amp principle. Okay, when V out is 0, then the output of LCD is also going to be the 0. Means without weight, the output is displayed as 0 only, 0 ounces or 0 grams. Yeah. After applying the weight here, what happens? The weight is going to be applied on this arms of this Wheatstone bridge. Then some of the resistance are going to be compressed, some of the resistance are going to be the stretched, so that its resistances are going to be changes. When the resistance is going to be changes, the bridge is no more in balanced mode. Then V plus and V minus are not at all same now. So because of the difference between V plus and V minus, the V out will be developed, which is proportional to difference of V plus and V minus, which is proportional to the weight applied here. Yeah. Once V out is applied, which will be the analog quantity, hence it is to be converted to the digital by using this analog to digital converter. Then the digital value will be given to the microcontroller. Okay, and the microcontroller through the LCD controller, it is going to display its weight in terms of either grams or ounces in this LCD. If there is a plate weight, so on plate we are going to apply weight, right? So that plate weight is to be reduced. That plate weight is to be subtracted, right? So for that initially, so we are going to measure that plate weight, and then by using these which is at a microcontroller, we are going to set it as 0. We call it as nullifying the weight. Okay, and coming to the microcontroller viewpoint here, for implementing this microcontroller, we require many number of ICs. Maybe for this switch from bridge one IC, for amp off amp one IC, for ADC one IC, for one microcontroller one more IC, for LCD controller one more IC. So for implementing this using other microcontrollers or simple microcontrollers, we require many number of ICs. And if it is implemented with the msp430 microcontroller, especially this 5x series microcontroller, okay, so we'll require only one microcontroller other than simple sensors and LCD screen. Why? Because the msp430 5x microcontroller, which is containing, which is accepting differential inputs V plus and V minus, just like op amp accepts V plus and V minus. Therefore, msp430 microcontroller itself containing the op amp. As well, it supports ADC, and as well it supports LCD controller. LCD controller is supported by this from 3x series onwards. Therefore, these all things which are in this dashed rectangle, so which is going to be implemented with only one microcontroller, and with a simple sensor to sense the weight, we require the sensors and the LCD screen. So with this, what we can justify here is we can implement a simple embedded system using msp430 with very easily. This is the one example. One more example here is the electronic die. The electronic die that you can observe in the next diagram. So using other microcontrollers, the electronic die can be implemented with requiring of three microcontrollers. The same thing when implement with our msp430 microcontroller, it requires only one microcontroller. So this is the advantage with the msp430 microcontroller 5x series. I hope you understood the importance of msp430 microcontroller for building an sample embedded system. Thank you.